this is the most interesting and the easiest chapter of our entire syllabus, factorization of polynomials. To start with the chapter, just see the introduction, 5 to 10 minutes, and that's it. That's the chapter. If next 5 to 10 minutes you understand completely, then I can say you understood the entire chapter. In front of you, I am writing a polynomial. Okay? X square minus x minus 2. Which type of polynomial it is? It is a quadratic polynomial because highest degree is 2. In other words, I can say it's a quadratic trinomial because there are 3 terms. Okay, but it's a polynomial. Okay, fine. I want to factorize it. So now see how I am writing this. There are some basics which you should know. I'll write here is fx is equal to x square minus x minus 2. I wrote here fx. Now what does this f indicates? What does this f means? F is the name of function. F is the name of function. Why this x? Why I have written this x within the brackets of f? X, this within the bracket, whatever variable is there, it shows the variable of our expression. Whatever alphabet we have within the bracket, it shows the variable of our expression. So suppose I give you another expression as y square minus 7y plus 9. So here you will write f of y, because within the bracket now I wrote y because my expression deals with the variable y. Similarly, not necessary always that you should name it as f only. We can write g also. Any alphabet you can write. But normally we don't use x, y, z, a, b, c and all. Generally it's more used f, g and all. So now g is a function in terms of y. And what's the function? Function is this. Similarly here f is the function in terms of x. The variable is x and this is the case. Okay. Now students, what I need to do is, I need to find the roots of this. This concept which I am teaching you, we are studying in maths since 6th, 7th and 8th. I want to find roots of this polynomial or this quadratic trinomial. Okay, I'll erase this. Okay, I want to find roots of this. So what I am doing is I'll do it by trial and error method. I don't know what are the roots of this polynomial. Okay, I'm finding roots. So first I'm supposing put x is equal to 1 just by trial and error method. Okay, just मेरे मन में आया, let's put x as 1. So I'm substituting at the place of x 1. So now what will happen? Wherever I have x, I'll substitute 1. So here it will be f of 1. F of 1 means the name of the function is 1. The name of the function is f. And I am substituting 1 at the place of x. Okay, is equal to x square. So I'll put here 1 square minus at the place of x 1 and minus 2 as it is minus 2. So 1 square is 1 minus 1 minus 2. Plus 1 minus 1 goes off, but I'm left with minus 2. I'm left with minus 2 over here. Now you tell me students, now let's discuss something. You know everything. Since 6, 7, 8 we are studying this. You know everything. What do you mean by this minus 2? In mathematical terms we will say that x equals to 1 is not the root of this expression. I repeat again. I'll say x equal to 1 is not the root of this polynomial x square minus x minus 2. Why? Because my remainder is not equal to 0. I repeat again, if it would be the case that when I substitute it at the place of x1, and if it would be the case that here it comes as 0, then I can say that x equal to 1 is the root of this expression. Understanding? Okay. Now moving forward with the concepts of now this chapter, because I got a remainder, this is called as remainder, which is minus 2. I write here remainder. Remainder, which is not equal to 0. Now, when remainder is not equal to 0 or any other number other than 0, what I can say, and I can say, see here, when x minus 1 is divided by this polynomial whose name is fx, so I'll write fx. When x minus 1 is divided by fx, we get remainder as minus 2. Students, next 5 minutes please pay attention. Why I wrote here x minus 1, you must be thinking. From where I got this x minus 1? See, from here I got this x minus 1. What you need to do is, whatever you are substituting at the place of x, that thing you need to bring along with x. So when I brought this 1 along with x, it became x minus 1 equal to 0. Understanding? When I brought this 1 along with x, it was earlier x equals to 1. So when 1 comes on the left hand side, it becomes x minus 1 equal to 0. Okay, but this is called as the divisor. This is x minus 1 is called as the divisor. And this whole expression, this x square minus x minus 2, it is called as dividend. Dividend. In a traditional way, students, of dividing, suppose if I do something like this, I divide 9 by 4. So this 9 is called as the dividend, and this 4 is called as the divisor. Similarly students, what we did actually is, we divided this x square minus x minus 2, because this x square minus x minus 2 is what? It is dividend for us. By what? By a divisor, which is x minus 1. But the style of division is not like this, a traditional long division. What we do, we put x minus 1 equal to 0. So if x minus 1 equal to 0, we got x as 1, minus 1 goes on right hand side. So that's the reason I substituted x equals to 1. So this is same as you must be dividing this whole x square minus x minus 2 with this x minus 1. This is the same case. If at all you divide x square minus x minus 2 with x minus 1, it's the same as what we did over here. But only difference is we did in a certain different manner. And this manner by which we did, this manner is called as remainder theorem. That's it. I repeat again. If you divide x square minus x minus 2, which is your dividend here in case, and with x minus 1, this is x minus 1 is your divisor. So you must proceed with a long division method, and whatever remainder you must be getting, that remainder will be same as what we are getting here. You must always get minus 2 over here, because we got minus 2 over here. So instead of doing this long division method, we have done a different technique, and this technique of obtaining the remainder is called as remainder theorem. Okay, let's proceed further now. I just want to reiterate what I told, so please stay tuned on the board, all of you. Okay, please pay attention. Now, because we substituted at the place of x1, so that's the reason I brought this 1 on the left hand side. So it became x minus 1. So I told that x minus 1 is when divided by fx. Fx means this polynomial, we get remainder as minus 2. Okay. So what else you can say? I can say that x minus 1, this is our divisor, which we substituted as x equals to 1, because x minus 1 equal to 0 we put. So minus 1 goes on the right hand side, it becomes plus 1. So we substituted x equals to 1, okay, in this, and we got remainder as minus 2. And because we did not get 0, we get any non-zero number, so we say that x equals to x minus 1 when divided by fx, we get remainder as minus 2. So that's therefore x minus 1 is not a factor of given polynomial fx. क्योंकि रिमाइंडर 0 नहीं आया, कुछ और आया, either negative or positive, but it's a non-zero term. So we are telling that x minus 1 is not a factor of fx. Now you tell me, students, now you tell me, if at all I take another case on the right hand side, and if instead of minus 2, if I get remainder as 0, so what will be the change? The change will be, you will say that x minus 1 is a factor. That's it, students. Chapter is completed. This is the chapter. I conclude my the tips over here, that if at all you divide and you get remainder as a non-zero term, any term which is not equal to 0, either positive or negative, we say that the given factor is not the given, this divisor x minus 1 is not a factor of the given polynomial fx. Now let's take another case on the right hand side. In the same polynomial, students, in the same polynomial, I am taking another case. Put let's say put x is equal to 2 in the same. So wherever I have x, I have substituted 2 over here. So f of 2 is equal to 2 square, okay, at the place of x2, minus 2 minus 2. 2 square is 4, minus 2 minus 2. Minus 2 minus 2 is minus 4. 4 minus 4, it's 0. Now can I say, students, this is my remainder, and my remainder is 0. It is equal to 0. So last case I was getting non-zero remainder. Now I am getting a 0 remainder. So what I'll write? First of all, this orange color I'll write as it is over here. At this place, I substituted at the place of x2. So that means we are speaking about x minus 2. We always bring that number on the left hand side. So now can I say, students, can I say I got this as my remainder? I'll just write r over here. So I'll write here when x minus 2, here in this case x minus 2, we will say, I know you have substituted 2, but when in the terms of division we speak in the terms of x minus 2. We bring that number on the left hand side. When x minus 2 is divided by fx. Fx means this polynomial. When x minus 2 is divided by fx, we get remainder as 0. We get remainder as 0. In the previous case, students, we got remainder a non-zero, minus 2. Okay, and please see here. In the previous case, because we got a remainder other than 0, we wrote that x minus 1 is not a factor of given polynomial fx. So, but here what I will write? Here I will write that therefore x minus 2 in this case is a factor of given polynomial fx in our case. That's it, students. This is the chapter. Believe me, this is the chapter. Just in 1 minute, I'll summarize everything. First, in this polynomial, I was substituting at the place of x1. So substituting in the place of x1, we get a non-zero term over here. This non-zero term which I get, or any term which I get here, it is called as remainder. But if your remainder is not equal to 0, it's any other number other than 0, we say that, if I bring this 1 on this left hand side, so we say that x minus 1 when divided with this polynomial fx, I got remainder as minus 2, and this x minus 1 is not a factor of given fx. Reason is because remainder is not equal to 0. Agar remainder 0 ho jata, so we would have told that this is a factor. Okay, coming on this case, now I just tried with another number, x equal to 2. So I substituted at the place of x2 and I got the answer, the remainder as 0. So now I will say when x minus 2, this 2 I will bring on the left hand side, it became x minus 2, is divided by fx, we get remainder as 0. Okay, so now therefore this x minus 2 is a factor of given fx. Now why we are writing it's a factor? Because we got remainder as 0. So to summarize our discussion, agar remainder 0 aa jata hai, if a remainder is 0, then we say that the given divisor is a factor, and agar remainder 0 nahi aata hai, we get any number other than 0, we say that given divisor is not a factor. Please, this is very important, please copy this. The first question on the board, students, I'll categorize this as type 1, just finding remainder. Such questions in this manner only, such short questions are now not asked in the board exams, but just to start with, to build a concept, I took this question. This question was asked in 2000 board exam paper, ICSE. Now find remainder when this polynomial 2x cube minus 3x square plus 7x minus 8 is divided by x minus 1. Okay, what will be our first step, students? What will be our first step? My first step will be to equate the divisor by 0. I repeat, my first step will be to equate the divisor by 0. This is our divisor and this is a dividend. So I'll equate my divisor by 0. Let x minus 1 is equal to 0. Therefore x is equal to, minus 1 comes here, becomes plus 1. X is equal to 1. That's it. Now they have not named this polynomial. We'll give the name. So I say let f of x. I gave the name as f. Name of the function as f. And I wrote here x because it deals with the x. 2x cube minus 3x square plus 7x minus 8. 2x cube minus 3x square plus 7x minus 8. Now what I need to do is I just need to substitute at the place of x this 1, because we are dividing actually this polynomial with x minus 1, but we are following remainder theorem. So in remainder theorem this is a new good technique. So now it comes f of 1. So 2 1 cube minus 3 into 1 square plus 7 into 1 minus 8. At the place of x I substitute 1. 1 ka cube is 1 only, okay, and 2 ones are 2, minus 1 ka square is 1 only, and 3 ones are 3, plus 7 ones are 7, minus 8. Now I can say let's add the plus terms. So plus 2 and plus 7 comes to 9, and minus 3 and minus 8 comes to minus 11. So I am remained with minus 2 over here. So tell me, students, do I get our answer as 0? Did I get the remainder as 0? No, my remainder is not equal to 0. That means x minus 1, this x minus 1 is not a factor of this given polynomial. Okay, but they have not asked us. I'm just sharing an extra information with you. They have just asked the remainder. The remainder is minus 2. Find remainder. So remainder is minus 2. So remainder is equal to minus 2. That's it. This is the answer.